portion of it. The skills that you're about to work on today with the evaluation of polynomial functions is one of the most important skills that you're going to use in this unit. It's something that will allow you to factor. It's something that will allow you to simplify quickly. It is an extremely helpful method of solving some of these problems. Tomorrow then we'll get into the actual graphing portion of the polynomials. There really isn't like an H and a K shift because every polynomial is a little bit different, but we'll do that stuff tomorrow as well before we get into 6.3. Yes, sir?
Will it be similar equations or
well, let me show you here. A polynomial is nothing more than just anything that's written in this order. Don't write all of this down. A polynomial is just something that looks kind of like this. Oops. A polynomial is some function in terms of, they write it as f of x, a function of x. It's called function notation. Remember, f of x is synonymous with y equals. Basically means the same.
Get for like all of algebra 1 and then
yeah, and that's all it is. It means the same thing. It's kind of helpful to know that, isn't it? Now you're okay there, right?
Yeah, no, I'm good.
is there a chance for three-dimensionals?
What's that?
Like if you have like a sphere,
Mhm.
how would you graph something like that? Would it just still be in like flat circles?
There actually is a way to graph in 3 dimensions with your x, y, and z plane. It's not a skill that we even work. We haven't done that forever. It's not a big
We're
deal.
letting that in design.
In everybody's x, y, z planes, depending upon the book, everybody goes different on how they plot it out. It's not that difficult. If you want me to show you, I'll show you during class. But it's not that tough. So here's the thing. When you're dealing with a polynomial, you're always going to write your polynomials in what's called descending order. You probably remember that, right?
Yeah.
Descending order meant what?
On the
Small.
biggest
Biggest and small. What is the biggest that we're looking at here? The biggest exponent, the degree. So when I'm looking at this function here, f of x, if I'm going to write it as a good polynomial, I would write it in descending order. 5x to the 4th minus 21x squared plus 14. Now, each bit of this equation has important parts to it. This first term, this a sub, wow, I'm messing up. That a sub n is called the leading term. It's the leading term's coefficient. That's it. Okay, it's the leading coefficient. The highest power that you have when it's written that way, the n, is the degree of the function. So this is a 4th degree polynomial. And then the last term, this constant, is this a sub 0. This is your constant of a polynomial. The constant has some important parts to it. If you think about what the constant did in slope-intercept form, what did the constant represent in slope-intercept form? The y-intercept. What do you think the constant here is going to represent? The y-intercept. Because here's what I want you to think. When you're talking about slope-intercept form, if I just have something where it was y equals 2x minus 3, when I wanted to work with the y-intercept, that's when x equaled what? 0, correct? So if x equaled 0, your y value was negative 3. So that became your y-intercept. It works the exact same way with polynomials. If x is equal to 0, your y-intercept will be your constant. Does that make sense?
Yes.
So you're able to, no matter what, right away find one set of ordered pairs for a polynomial for graphing. I don't know what this graph is going to look like. I know it's a 4th degree polynomial, and I know it has a y-intercept of 14. That's all I know. Okay? Does that make sense?
Mm-hmm.
The other part of this is another thing that we don't really get into too much, but it's the names of polynomials. So this is just FYI, you don't need to write all this through here. If your polynomial looked like this, where it was y equals 2, it's just a constant. Okay? It's just a constant. If it's linear, that's your mx plus b. Okay? When it gets down into the quadratic stuff, that's when your stuff is squared. Oh, your phone. Thank you. Your quadratics. We all knew that. Squared ones were quadratics. Cubed ones are called cubic. Fourth degree ones are quartics. I'm sure there's other names, but I don't care. We'll probably just call them like fifth degree polynomial, sixth degree polynomial, eighth degree polynomial, and so on. Okay? That's what that basically is. You'll notice that everything is written in that nice descending order, and it will always be written into a descending order. When you guys had Algebra 1, you had a section in there that had ascending and descending order. I'm hoping that your teacher told you that the descending order was going to be the most important method, right? No? Well, now you know.
No, I know.
And knowing's half the battle.
What if you know you're gonna die? Then
Yes, sir.
after that,
So does it mean like if it's 40, for example, does that mean that there's 4 terms or that the highest exponent?
The highest exponent is 4.
Alright. So
Because in theory, you could
so
have...
like even if you had a just f of x in the space of 4x to the 4th, that would
It'd still be important. Yeah, I was just going to say that. For example, if you had f of x equals 2x to the 4th, that's still a 4th degree polynomial. It just doesn't have any other junk to it. Okay. Where would its y-intercept be in this case? 0. Very good. Because there's no constant. See what I'm saying? It blends that
The
way.
amount of terms is fine.
Correct. Yeah. When you're looking at it in terms of degrees, it's just going by the degree. Okay. So as you build out of this, there's a couple of things that you guys have already done. One of the things that you guys have done with polynomials is that you guys have worked with what's called direct substitution. Plug and chug, we used to call it. When you go back to your, think back to what you guys did in the algebra, some of the first function things you guys saw might have been like f of x equals 2x minus 1 and g of x equals x plus 2. And then you had a worksheet that might have said, what is f of 3? What is g of 2? And so on. Remember seeing that? Now, if I'm looking at that and I say, what is f of 3? Which equation would I have to pick? The f equation. And what would I do with that 3? I'd substitute in for x, so I would get 2.
F of x means function of x. What is g?
It just means it's an extra, it's another function. That's all it is. It's like the second equation. Okay. So this would wind up being, what, 5? So this generated an ordered pair. Your f of 3 is your x value, 5 is your y value. This is how you would get your ordered pairs. This would be 3, 5 for this function. Okay. It does the same exact thing when it gets into polynomials. The only thing that's different is that you have to worry about your parentheses and your exponents when you're doing your calculator. So when you get to something like this, I'm going to use direct substitution to solve this out. And it'll look like this. 3, negative 2 to the 5th, minus negative 2 to the 4th, minus 5 times negative 2, plus 10. And nowadays, you guys have these nice fancy calculators that have the ability to change your degrees. You have parentheses, you can group stuff around to figure out what is f of negative 2 going to be. What will be your solution here? What is the ordered pair at negative 2 comma something? What do you get when you substitute in? You get the ding.
sounds perfect.
What's that?
I'm gonna think it sounds perfect. Probably just like sit around to the pages.
One, and at some point in time, they probably said, pull my finger. You never know. Negative 92. Anybody else there?
Yes.
So basically what you're telling me is that when x is negative 2, y is negative 92.
So you just like substitute the x and
Yep. Yep. This function, this is called function notation. Function notation is a lot of direct substitution. you're replacing x with negative 2.
I like
Katie, you give me scrunchy face. What's wrong?
I keep getting negative 60, but
Did you type it in? Did you miss a sign? Did you accidentally use a negative and not a minus sign?
I did. Oh, I cleared it, so
Come on.
Well, don't do it all at once. No, no, no. This is why you're doing that. That's why you're doing it wrong. Because negative 2 to the 4th power, wouldn't that be a positive number?
yeah.
Because you would have negative, because you have the parentheses in
Oh, so you would get it just like that?
there. Katie, what I want you to do, type it exactly the way I wrote it. Allie, Katie, who? Can I call you your sister's name?
Yeah.
I'm sorry, because I don't like your sister. You're nicer than she is.
Oh,
I agree.
I'm sorry. Oh, God bless it, I'm sorry.
God, that's serious, sorry.
It's like calling me dinner.
Never called me Kitty.
You know what I realized when I was looking at such a kid in the hall? It's like bomb.
She's something.
Mine's gonna be a stroke.
What's that?
Your shirt's gonna give you a stroke.
I hope not. Did it work now, Ms. Irie? Yes, ma'am.
Out of
Are you like
everyone
me?
whose oldest siblings you've
No.
had,
No.
what do you think has been like the most annoying?
Not my one.
That's true.
Your sister.
Did it work now?
I don't have my phone. Wait, yeah, is it?
Are you signing that?
There's another way to do this.
This is for that same equation.
There's another, this is the same thing.
Not equation,
Function.
function.
All right? There's another way to do this. It's called synthetic substitution. It's not. Synthetic substitution,
What was the previous one?
direct substitution. Synthetic substitution starts with something like that. It kind of looks like an upside down division bar. Okay? What you do then is you're going to pluck out all of the coefficients of your polynomial. Now, what you have to pay close attention to is, notice in the polynomial is a 5th degree polynomial, and if I went through all of the descending order, I should have a total of 6 terms, 5th degree, 4th, 3rd, 2nd, regular, and a constant. So I should have 6 total terms, but my polynomial only has 4. What do I have to put in place then? Zeros, very good. I have to put in placeholders for 3x to the 5th minus x to the 4th plus 0x cubed plus 0x squared minus 5x plus 10. Now, I'm only writing this out for probably the first example to show why the placeholders go. What's up, sir? Hey, tell them that synthetic substitution and long division and stuff like that is important. Because you use it all the time.
Hey, sir.
Yeah.
Sir, hi.
See it.
No.
Now, the reason that you got to put in those zeros is because they're just placeholders. Synthetic substitution, or synthetic division, however you want to get to this eventually, needs to have everything written in a descending order without missing a power, without missing a single degree. So what you do is you pluck out your coefficients. 3, negative 1, 0, 0, negative 5, and 10. Okay? And we're substituting in negative 2. Here's how this works. You drop the first term. You take negative 2 and you multiply times 3. What do you get? You write that here. Now what's negative 1 plus negative 6? What's negative 2 times negative 7? Is it positive? What's 0 plus 14?
14.
Double 14, what do you get? Now remember, it's negative. 0 and negative 28.
Sound like you're gonna see.
Double it. What do you get? Adam? Double it.
That's how'd you get,
I get it.
how'd you get negative?
That's a whole hell
Yeah,
of a
how'd you
lot
get
of
negative 20?
Negative 28 we got from 14 times negative 2. Ladies and gentlemen, this method of what's called synthetic substitution is a precursor to factoring. You will use this over and over and over and over and over again. This is a skill that just, I mean, obviously it's the first time you've ever seen it. It takes a little bit of time to get used to it, but it is extraordinarily straightforward. As long as you remember when you're writing it down to not miss a negative symbol or put your placeholders in. Okay? Let's do another one. So again, what we're doing here is that our x coordinate was negative 2, our y coordinate was negative 92. You're being very lifty today. I have a function. F of x is 2x to the 4th minus 8x squared plus 5x minus 7. And I want to figure out what f of 3 is. What's that? I want to use a synthetic substitution. So once again, I'm pulling out my coefficients. I put a 0 in for a placeholder at the x cubed term because there isn't one. And then I start with my method. I drop the first term. 3 times 2 is 0 plus 6. 3 times 6. Negative 8. It's okay. I know. I'm sorry, I'm on the wrong side here too.
Yeah.
All right. So negative 18 is 10. 3 times 10 is?
30.
30 plus 5 is?
35.
Okay. Double 35, what do you get? 70. Add 35 more to it, you get?
105.
And then add them together.
Wait, for the last one,
Yeah.
just double it.
Oh, and it's a negative. Wait, so.
What I did here was mental math. I didn't know what to do with 3 times 35 in my head, but I know if I double 35 it's 70, and I can add 35 to 70 quickly. That's what I did. That's fine.
What is this finding? Like, what is 98?
Negates the y value when x is 3.
Okay.
Okay? In essence, what this is finding us are sets of ordered pairs. What this is eventually going to find us is the following. We're going to be able to take a polynomial like 2x to the 4th minus 8x squared plus 5x minus 7, and we're going to be able to factor this somehow, some way. And the reason that we're going to be able to factor this is because we're going to use synthetic, what's called synthetic division, which mirrors the same process. This process allows you to do so much more stuff with polynomials once you master it. And it's not, like I said, it's not like it's a horribly scary process to do. It's just working with signs and adding and multiplying. A lot of it is mental. Okay? Remember, this stuff was all developed prior to when they had the calculators with parentheses and the exponents. They had to come up with a process to make this work. And this works.
That's so weird.
It is, it's weird that it works, but it's kind of cool because it's easy. It's not that it's tough. Okay? Let's do one more because we've got like a minute. So here's negative 2. I'll put in your coefficient for you. Negative 2, 3, negative 5, 2, negative 6.
We're doing the first,
Yeah, just do that one. What I did there was just kind of, I already took care of the coefficients for you. And I want to synthetically substitute in negative 2 for x and see what I get for y. Let's see. Remember, drop the first term. Get -2. Multiply. Add. Multiply. Add. Multiply. Add. Multiply. Add. Did you get -86?
Yep.
I wrote +6, but other than that.
All right. Yeah, and see how easy it is to make just a dumb mistake with the sign there? This is where you gotta be very careful with your science, guys. Yes, sir?
When we graph this tomorrow, will we be getting giant numbers like -86?
There's a different way to graph these things. We're gonna look at it a little bit differently than what this is, okay? We'll worry about that tomorrow, okay? Here's what I want you to do. This is section 6.2 in the book. It's page 334. And I want you to do the synthetic division problem, not synthetic division, synthetic substitution problems on 334. It's 37 through 46. The problems themselves start like this. When you read them out of your book, just write them down like this right away. Yes, sir?
Do we have to use a synthetic?
I want you to use synthetic because this is, like I said, this is a process that I want you to master, because when we get into fundamental theorem of algebra and things like that, of factoring out these crazy polynomials, using this process just makes everything easier. Okay? Yeah, they're going to give it to you just like this. It'll look just like this, parents, where they'll say, what is x of 4? All right, so you just, if you want to write that out automatically, that's fine. It just saves you some space. Don't forget placeholders when you're missing a degree, okay? That's usually what you'll mess up, or negative.
Well, I got nominated for
If you have a problem where there's,
state representative.